Reasoning is the process of thinking about something in a logical way in order to form a conclusion or judgment. You are most likely using some form of reasoning as you make everyday decisions. For example, have you ever been faced with a decision about what to purchase? Maybe an iPhone versus an Android. So before you make a conclusion or judgment, you weigh the pros and cons of each. Well, a lot of my friends have the iPhone, but the Android is much cheaper, and at some point you'll use this information to come to some sort of decision. One of the reasons that we study geometry is to sharpen our reasoning skills. We're going to be exploring two types of reasoning in this course, inductive and deductive reasoning. But for the time being, we're going to start with inductive reasoning. So this friendly frog is going to start to spit out some numbers. And what I would like you to do is look for a pattern to emerge. So here we go. So hopefully you're starting to see a pattern emerge. What I would like you to do is take a guess about what the next number is going to be. Did anyone say the next number will be 11? Let's find out. We'll hit the frog one more time. All right, if you said 11, you're correct. So when you make the statement, the next number will be 11, you don't really know if you're going to be right, but you've recognized the pattern, and so you've made a conjecture. A conjecture is an unproven statement that is based on observations. You observed the pattern 1, 2, 3, 4, 5, and you said the numbers are increasing by 1 every time, so I think the next number will be 11. So let's make another conjecture. This time, let's make the conjecture that the next number will be 12. Let's find out. Well, the next number wasn't 12, so clearly conjectures could be true or false. Now, the entire process that we just engaged in, looking for the pattern and making observations based on that pattern, and then making a conjecture based on that, that's all part of inductive reasoning. The process that we just engaged in is called inductive reasoning. We use inductive reasoning when we find a pattern in specific cases and then write a conjecture for the general case. So, part of geometry is the search for truth. You can't handle the truth, but maybe you can handle the truth. So let's take a look at this conjecture. The sum of any two numbers is odd. Now we know that a conjecture could be true or false. So let's take a look at trying to prove whether this conjecture is true or false. So let's take a look at some examples. 3 plus 2, the sum of any two numbers is odd. 5. Well, that's odd. Let's take another example. 7 plus 4 is 11. Well, that's odd. Let's take another example. 3 plus 10. Well, that's odd. But maybe you've noticed that this conjecture is not true. Maybe in your mind you've thought of an example that proves it false. So let's look for an example that proves it false. How about 3 plus 5? Well, 3 plus 5 is 8, and 8 is even. That proves that this conjecture is false. This one example here that proves that the conjecture is false is called a counterexample. A counterexample is a specific case for which the conjecture is false. It's much easier to show that a conjecture is false than to show that it is true. We could come up with an infinite number of examples to support this conjecture. If you just take an even number like 8 and add it to an odd number like 7, you're going to end up with an odd number. So we could support this conjecture infinitely, and therefore proving it true is difficult, but proving it false is much easier. You only need one counterexample to demonstrate that the conjecture is false. So when you're looking to prove something to prove that something is true, it's actually easier to try to find a counterexample and prove that that is false instead. And here's a recap of the big ideas in this lesson in case you didn't get a chance to write anything down.